Okay, so let's get into orbital notation. I told you at the end of the other video that you're going to show boxes for each orbital. An S orbital has 1 box, a P has 3, and a D has 5 boxes that go along with it. And these boxes just show the electron pairs. So we are going to draw the electrons in the orbitals and show how they're feeling up in each orbital. So if you see an S, you're automatically going to draw 1 box. If you see a P, you're going to draw 3 boxes. And then if you see a D, you are going to show 5 boxes. Let's go ahead and draw out our boxes for phosphorus. So we have the 1s orbital. And you don't have to label these. I'm just kind of doing this to show you right now. Then we have the 2s orbital. And the S gets 1 box. Then we have the 2p orbital. Told you it gets 3 boxes because a p orbital can hold 3 pairs. Then we have the 3s orbital. It's going to get 1 box. And then we have the 3p orbital, which will get 3 boxes. Okay, so an S, a P, an S, and a P. All right, so with orbital notation, I told you that we're showing electrons and how they're pairing up. There's 2 rules or principles. The first one is called the off-ball principle. And that just says that electrons, and anytime you see me draw an E negative, that is a representation for an electron. Electrons occupy the lowest energy level orbitals first, then fill up. So that's the off-ball principle. And then there's Hund's rule, which says basically orbitals fill up electrons one direction and then pair up in the other direction. So you're going to see what I'm talking about in just a moment with these. All right, so this S orbital is filled. So we're going to start with an up arrow and a down arrow because it's got 2 electrons. So this is showing 1 electron going one way and 1 electron going the other way. It does not matter if you put your down arrows first and then your up arrows, as long as you're showing that the electrons are spinning opposite ways. So I always go with up arrows first. So, but like I said, if you want to do your down arrows first, that's fine. It's not a rule that you have to go with up arrows first. The S orbital was filled. It had its 2 electrons in it. We're going to do an up and a down. P orbital was filled. It had 6. So we're going to do an up, and up, and up. And then we're going to fill in with a down, and a down. That's what Hund's rule is saying. They all fill up one way, and then they fill up with the opposite spin. It doesn't really matter if the orbital is completely filled, but just to get used to it, go ahead and start doing it that way. The S orbital has 2 electrons in it, so we did the up and down. Now the P has 3, so we're going to go all ups first. So there will be no down arrows. An incorrect way for this would be if you did an up and a down, and then an up. So that way would be incorrect. They all fill up first, and then they go back in and fill down. Okay, so let's label out these. We've got a 1s, a 2s, a 2p. I'm just listing the orbitals here. We've got a 3s, a 3p, a 4s, a 3d, and a 4p. Okay, so S's get 1 box. P's get 3 boxes. S's get 1. P's get 3. S's get 1. D's get 5. Okay, and then our last one is 4p, so that gets 1, 2, 3. So we're going to go through here and show the electrons. First one has 2, so we're going to do an up and a down. Second one has 2, an up and a down. Third one, the P, has 6, so up and down in all of them. This S has an up and a down, the 3S. 3P is filled, so all of those are having an up and a down electron spin. The S is full, so it has an up and a down. The D is full, so all these are up and down. Now your P is not filled. If it was filled, it would have a 6. So it's 4P5. So we're going to do the up arrows first. 1, 2, 3. And then we're going to fill back in with the down arrows. 4, 5. Okay. Let's do this one. We've got our 1S, our 2S. We've got our 2P, a 3S, a 3P, 4S, 3D, 4P, and then we've got a 5S. S's get 1 box. P's get 3 boxes because they hold 3 pairs. 4S gets 1. Our 3D is going to get 5. The P is going to get 3. And 5S will get 1. So all of these are filled all the way through this one because it ends on 5S2 and that one's filled. So that just means that all of these are going to have an up and a down arrow in all of them. So that is orbital notation. And remember, it goes along with the off-ball principle. It occupies the lowest energy level orbitals first. So that's why we start with the S's, and then we run into the P's, 3 S's, and then we get into the D's. So we follow the order left to right, top to bottom, what orbitals it's filling up. And then Hund's rule saying that it fills up one way and then it fills up the other way with the electrons. Remember, electrons spin one way and then the other one spins the other way. All right, so that's orbital notation. Now let's look at noble gas notation. Okay, so noble gas notation. The noble gas before it whatever element you're working with goes in brackets, and then you write what comes after it. So if we look at phosphorus, phosphorus is right here. The noble gas that was above it is neon. So we're going to put neon in brackets. And then we're going to list the orbitals that are filled up after neon through phosphorus. So we're at neon, then we're going to go 3s2, 3p3. And all the brackets are saying is that these include all of this stuff up until the noble gas, and then you just write the orbitals that are filled up after it. So if we do the same for bromine, if we look, bromine, the noble gas that's above it is argon. So we're going to put argon in brackets. Now we're going to list everything that comes after argon up to bromine. So it'll be 4s2, 3d10, 4p5. So it'll be 4s2, 3d10, 4p5. And then if we look at strontium, for putting that in noble gas notation, the noble gas before it was krypton. So we're going to put krypton in brackets. That means we included everything all the way up through krypton. And then after krypton, we drop down to the 5s, and it's 5s2. So the noble gas notation is just a way of shortening it. And you can still look at these. It ends on 5s2. You can check 1, 2, 3, 4, 5s2 should be strontium. If it ends on 3p3, then you should be able to find 3p and go over to 3, and it should be phosphorus. Or if it's 4p5, we find 4p, 1, 2, 3, 4, 5, it should be bromine. So noble gas notation is just a shortened way to write out electron configuration.